Hello guys, today I will gonna speak on the bio-inspired algorithm and its use in order to maximize or minimize a certain objective function. So we can use these bio-inspired algorithms in the optimization problems. So the example of the main example of the bio-inspired algorithm is the anti-colony algorithm, particle swarm algorithm, and also the FireFly algorithm, which is the main course here in our video. So the FireFly algorithm is a bio-inspired algorithm. The FireFly is bio-inspired algorithm which is used in order to make optimization for a certain objective function. Okay, so here is the main equation for the FireFly algorithm, which is, let's read it together. Xi is equal to xi plus b naught e to the power minus gamma rij squared times xj minus xi plus alpha rand minus half all bracket, where xi is the position of the FireFly I, xj is the position of the FireFly j, b naught is the attractiveness at xi, gamma is the absorption coefficient and it's always equal 1, rij is the distance between the FireFly I and the FireFly j. The distance is very important here in our case because you know that the brightness or the lightness of any FireFly decreases with the increase of the distance. It is inversely proportional to the square of the distance between each two FireFly. Alpha and rand is a random number generated by MATLAB. So here the main course or the main conclusion here, in order to use the FireFly algorithm in the optimization problem, this what happened. The MATLAB code initializes a group of FireFlies in the search space that the user enter it according to lower bounds or upper bounds according to the main objective that the user got. For example, the user got the profit share of a certain company, the starting time of a certain power station, the wages of certain employees. This got upper bounds and lower bounds, and the number of the employees or the number of the power stations. These parameters are entered in the MATLAB code in order to the MATLAB code to initialize the number of FireFlies, which is not less than 100, in order to get a specific results in the search space. So we've got here xy dimension for simplification in order to illustrate that. Here we've got FireFly 1 and FireFly 2, but in 2 dimension, which means we've got only 2 employees or only 2 power stations, and we've got FireFly 1 and FireFly 2. The main idea is the FireFly 1 will move toward the more brighter FireFly, which is 2. In case the FireFly 2 is more brighter than FireFly 1, so FireFly 1 will move to the FireFly 2 in case of the maximization problem. In the same case, if we've got a minimization problem, the more brighter FireFly will move to the less brighter FireFly. So this is done by the MATLAB code, and as we said that the brightness of a FireFly will decrease with the increase of the distance between between the two FireFlies. For example, if there is another FireFly here which is more closer to this, so this will go will move to the other FireFly because the brightness seen by FireFly 1 is more than that seen by FireFly 2. This is done by using the MATLAB code. If you need an extra session how to make a MATLAB code in order to illustrate the FireFly algorithm to a real problem, please write to me in the comments, and please make subscribe to our channel in order to see every and single video that has been released on this channel once it is uploaded. Thank you so much for that. I hope that the FireFly algorithm is little bit clear in order to understand and in order to apply it to several operations in our real life. Thank you so much for that, and see you soon. Bye bye.